All right, so you're welcome back. So in this video, we'll be looking at how to how to solve a linear system of equation using what we call the method of Gaussian elimination. Now, this method of Gaussian elimination, it relies on what we discussed in the last video, which is the echelon form of the row echelon form of a matrix. Now, here we have three outlines. So the first thing is you form the augmented matrix. We discussed this in the first video. So you write this, you convert the system of linear equation into the augmented matrix form. Then you try to convert the matrix into what we call the row echelon form. That will be the second step. And how do you do that? You can achieve that using the elementary row operations. We'll talk about that shortly. Then finally, we will use what we call the back substitution. Now, let's talk a little bit about the elementary row operation. Elementary row operation, these are the operations that can be applied to a matrix in order to convert a matrix which is not in echelon form to become a matrix in an echelon form. Now, there are only three operations that we can use. So let me just run us through the three operations. So these are the operations. The first one is this one, is that you can add a multiple of one row to another. The second one is that you can multiply a row by a non-zero constant. We will see all this when we take example. And the third is that you can interchange two rows of a matrix. So it will not change the system of your equation. So these are simply what we mean. So you can multiply a particular row, let's say row 1, for example. I can multiply row 1. I have row 1. And then you can add it to another row, say row 2. Then that will be your next row. And then you can multiply a particular row by a constant, and you can interchange. So this is what we mean by interchange, means Ri can become Rj. So let's go and take a particular example and see how we apply this elementary row operations. Okay, so this technique is invented by Gaussian himself, so that is why it is called Gaussian elimination. So let's take this following example. That is example number 3. So for example number 3, we're going to solve this system of equation using two methods. The first method is called Gaussian elimination, and the second method is Gauss-Jordan. So let's start with the first method. So for the first method, all you need to do is you need to just rewrite your matrix, your system. So this is the system here. Okay, so this equation, as you can see, I can transform this. So let's start with Gaussian. So we're trying to use Gaussian elimination. So to use Gaussian elimination, this equation, you would transform it into this matrix. So where is this matrix? Here. This is just 2, 3. These are the coefficient of x. And the coefficient of y will be 5 minus 2. And then you can put a dotted line, and this right-hand side, you can put it as -1 and 8. So this is what we call the augmented matrix. Right? Now, if you look at this matrix here, this is not what? It's not row echelon. Yes, because if you look at the first non-zero entry, this is 2. If you look at the first row, the first non-zero element you see is 2. So it's already violated the conditions. So now our target will be to convert this one to where? Will be to convert it to row echelon. And how do you do that? We use by what? So we will use row operations to convert the matrix into what? We convert the matrix into row echelon form. So what are we going to do? We're going to use this row operations. And how many types of row operations we have? Only 3. You cannot use more than that. Now, the first goal is that what? This guy must go to where? Must go to 1. And to achieve that, we can just use this row operation, because one of the row operation is that you can always multiply by a constant. You can multiply any row by a non-zero constant. So one of the non-zero constant is half. So half is non-zero, so I can multiply row 1 with it. And once we do that, if you multiply row 1 with it, here will become 1. Here will be 5/2. And the right-hand side is just going to be minus half. So we're done. So here will still remain 3. Here will remain -2. And here will remain 8. But if you are dealing with what? Row echelon, once you have your what? Once you have your leading entry, the number below it must go to 0. So it means that this has to go to 0. So this must go to where? So this now, well, let me use this. This has to go to where? It has to go to 0. Now, how do we take this to 0? We also need to use row operation. So what row operation can we use? We will use, so it means now you are keeping what? We're keeping our first row, which is nice. Now, this is this. And this is minus half, right? So to take this to 0, all you need to do is to take the what? The additive inverse of the number itself. What is the additive inverse of 3? Is -3. So we'll take -3. You will multiply it by your pivots. This is your pivot. Your pivot row is row 1. Then you add it again back to row 2. So it means you did -3 times row 1. So you have -3 times 1, which is -3 plus 3. This becomes 0. So -3 times what? This one. So -3 times 5/2, right? So which is going to be -15/2. So you have -15/2, then plus what? Plus -2. So this is going to be this -2. This is going to be -15/2. This is going to be -4/2. So this is going to be -19 all over 2. So you do the same here. -3 times half is going to be 3 over what? 3/2. So just watch me. You have -3. So -3 times add 1. So it is -3 times what? This one, which is 3/2. Then you need to add it with what? With 8, right? because this position here is 8. And 8 you can write as what? 16 over 2. So here you have 19 over 2. Then you ask yourself, is this okay? Is this row echelon? If it is row echelon, you stop, right? But now let's see. This matrix we have now, if you go, this is row 1. Row 1 is good. This is 1. But if you go to row 2, this is our row 2. These elements must also go to where? Must also go to 1 because it's the first non-zero element in row 2. So it means we need to apply another what? Another row operation. And here, how can we change this to 1? Just take the what? The reciprocal, the negative reciprocal, which is minus 19 over 2 r, no, minus 2 now over 19. Minus 2 over 19 r2. In that case, this will still remain as 1. This will remain as 5 over 2. And this will become minus half. Here becomes 0. Here is what? 1. Yes. And here is what? Minus 1. All right. So if you look at this now, this is what? This is row echelon form. Yes, because this is my pivot or my leading entry. Below it, everything is 0. This is my leading entry. Below it, there is nothing, so it's still fine. Now, so let's see our solution. This is when we are using Gaussian, right? So don't forget we're using Gaussian. So for Gaussian, all you need to do is just, once you have your echelon form, here, this, remember, this coefficient here is for x, this is for what? Y. So you can take the final answer for y. So this means that what? You can see that y is just going to be what? Minus 1. And then now you have to do back substitution. So back substitution means you go to the first row. From the first row, you will have x plus what? 5 over 2y. It's equals to minus half. Then you can substitute what? You can substitute y is equals to minus 1. So you have x plus 5 over 2 minus 1 is equals to minus half. And that means you will have x minus 5 over 2. It's equals to half. So x is minus half plus 5 over 2. And that means that x is just going to be what? This is going to be 2, right? 2. So what is the solution? So our solution, or you can say our solution is simply, our solution set contain only one answer, which is x is equals to 2 and y is equals to minus 1. Now, this is using what? Using Gaussian elimination, right? So let's now solve this same problem. Let's proceed to solve it using Gauss-Jordan. Using Gauss-Jordan. So now let's say Gauss-Jordan. Now for Gauss-Jordan, you require what? This will require the reduced what? You need the reduced row echelon form. But how do you get the reduced? So you just start from here. You continue from here. This is your row echelon. So you take this row echelon matrix, which is simply what? Which is simply 1, 5 over 2, dash, dash, minus half. This is 0, this is 1, and this is minus 1. So we continue from here. This is row echelon. So now to use, we need what? Okay, we use also row operations to what? To further convert the row echelon matrix to what? Reduced row echelon matrix. Okay. And now how do we do that? Now, what will be reduced? Reduced means that what? It means if you have your pivot, this is your pivot, this is your pivot. Now here, all the elements under it, they are 0. The element above it, there is nothing. But for the second row, this element, there's no element below it, but the element above it also needs to go to where? Needs to go to 0. So it means we want this one. We want this one to go to where? We want this to go to 0. Because if this can go to 0, then it becomes reduced row echelon. So how do we do that? Simply still by row operations. So we just take what's the anti-additive inverse of that number, which is minus 5/2. Now it's going to be multiplied by R2 plus what? R1. That will take the position of the entry. Now, remember, this our pivot we are dealing with is coming from row 2. So row 2 is fixed. So just repeat the entries for row 2. Okay, now how do we get this? Just apply this row operation, minus 5/2 R2. So it means you have minus 5/2 times what is R2? R2 is 0. The element here is 0 plus 1. So this will still remain 1. Minus 5/2 times 1 is going to be minus 5/2, right? Then plus R1. What is R1? R1 is 5/2. So here will become 0. Minus 5/2 times R1, which is, you can use this one or this one. This will just become 5/2 plus half. So you have 5/2 plus minus half. This is nothing but 5/2 minus 1/2, right? So this is just 4/2. And this becomes what? This becomes 2. So you can see that everything, just by one step, this now is what? This is reduced row echelon. So we can stop. So by Gauss-Jordan elimination, let me put, they are all elimination methods, so just different names. So directly, you can see that this guy, from the first row in Gauss-Jordan, you see that every row has a leading entry. So here you can see clearly X is just going to be 2 and Y is just going to be minus 1 directly. So the solution said it's simply 2 and minus 1. So if you are asked to just solve a linear system, you can choose any one you want to use. You don't have to use Gauss-Jordan. You can just stop at Gaussian elimination. But if it is specifically mentioned that you should use Gauss-Jordan, then you have to get up to this point, which is getting the reduced row echelon matrix. All right, so now we have one more example to take on this. This example 4. Here we're dealing with a matrix that is big. This is a big matrix. All right, so we will look at this Yes. So here we have 3 by 3. So here, just as we can see example 4, we have a 3 by 3 system. So we will start with the Gaussian elimination. So the first thing we do is to form the augmented matrix. So here you have a 3 by 3. So the coefficient matrix for X is just 1. For X it's a 1. Then 2. So the coefficient matrix. So this is going to be 2. This will be 3. And this is 1 minus 3 minus 1 minus 4. And this is 1. And this is going to be minus 1. And then the constant matrix is going to be 10, 7, 12. So this is what we have. So this is the augmented matrix. All right. Then what will be the goal? The goal is to convert this to the row echelon form. So as you can see, this is already 1. So this is our leading element for the row 1. So it means now we have to take this 2 and 3, we have to go to 0. And how do we do that? By row operation. So we can apply this, since this is 2, we take the additive inverse, which is minus 2 R what? R1, because R1 is our pivot row. Then for row 3, this is going to be what? Remember, row 1 remains the same. So let's look at the row 1. Let's just keep it 1, 1, minus 4, and 10. Row 2 is the one that we have minus 2R1 plus R2. And then this will be minus 3R1 plus R3. So we will use this operation now. Okay, so minus 2 times R1. So you have minus 2 times 1 plus 2. This will give us 0. Minus 2 times 1 is minus 2. Minus 2 plus minus 3 is minus 5. Then minus 2 times minus 4 is minus 8. Minus 8 plus 1. So you have minus 2. Yep. We have minus 2 times what? Times R1. So it's going to be minus 2 times minus 4, which is going to be 8. 8 plus 1. So this will be 9. Then minus 2 times 10 is minus 20. Minus 20 plus 7, it's minus 13. Then we go for the row 3. Minus 3R1 plus R3 is 0. Minus 3R1 plus R3. So you have minus 3 times 1, which is minus 3. Minus 3 plus minus 1. It should be minus 4. Minus 3 times minus 4 is 12. 12 minus 1 is 11. Minus 3 times 10 is minus 30. Minus 30 plus 12 is minus 18. So this is what we have here, right? Okay, now we can make this one to go to what? The next thing is that this one has to go to 1. This has to go to 1, right? because that is the second row. The first non-zero elements in each row must be 1. And that we can just use 1/5 minus 1/5 R2. Now we can do this. Why? Because it's one of the row operations. You can multiply a row by a non-zero constant. So in this case, this is going to be 1, 1 minus 4. That is row 1 minus 13. This still remains. Here will just be 0. Here will be 1. And here will be minus 9/5. And then you have 13/5. And then we can just replace, copy this one, minus 4, 11, and what? Minus 18. All right. Okay, now remember we're using Gaussian elimination. So these are the pivots. This is 1, 1. Then these will now have to go to 0. This one, because for Gaussian elimination, once you have your pivot, your leading entry, the entry below it has to be 0, right? And how can we achieve this? Simply by using the what's. So it means that we will keep what's. We will keep the first 1. This will still remain as this here. Since we're looking at this one, it means it's the row 2 that is fixed. So this is fixed here. We'll keep it just like this. So now this is going to be 4 R what's? 4 R1, no, R2, yes, it's going to be 4 R2 plus R3. So 4 times R1, so you have 4 times this plus this is still going to be 0, right? R2, this is R2, so this is 4 times 0 plus this plus 0 is still 0. 4 times 1 plus minus 4, this is 0. Then you have minus 9 times 5. So we have minus 9/5. Then we multiply this by 4. Then we add what? Plus 11. This will give you minus 36/5 plus 11 you can write as 55/11. And this will give us minus 36 plus 55. It's going to be, I think, 19/5. Right. Then the same way for the last term, we will take 4 and multiply by what's minus 13. 4 multiplied by minus 13. If you multiply 4 by minus 13, this is going to be what? This is 62, right? And then what do you do with that 62? You have to add it. Okay, not 13, sorry, because we are using R2. So R2 is the fixed. So it is 4 times R2. So it is 4 times, what is R2? Remember, R2 here is this one. So you have 4 times 13/5. Then you need to add it plus what? Minus 18. Right? So this is what we've got. And now how do you do this? This is going to be minus 62/5. Then this is also going to be minus 80. Is it minus 80? Yeah, this is plus here. So this is going to be minus 80 minus 18, which you can write as 90/5. So we have 62 minus 90, and this should be minus what's minus yeah, so this is going to be what? This is 52, 62, 52. So this is minus 38. over 5, right? Okay, minus 38 over 5. Then what next? This one has to go to where? Has to go to 1. This has to go to 1. So for this to go to 1, we need to perform which operation? We just need to multiply root 3 by the what? The reciprocal. So it's going to be something like this. It's just going to be 5 over what? 19 R3. And that will make this 0, 0, 1. And here you have 5 over 19 times what? Minus 38 over 5. 5 will cancel 5. 38 divided by 19 is 2. But there is a minus, so you have minus 2. Okay? Then every other thing remains the same. 0, 1, minus 9 over 5. And 13 over 5. 1, 1. Then what's this is minus 4, and here is minus 13. Okay, so now if you look at this, this is what? This is now row echelon, because this is 1, this is 1, this is 1. This matrix is in good. This one is row echelon form. Now, since it's row echelon, remember we're using Gaussian elimination. So what will be our solution? Since it's row echelon, then we can just get our answers directly, right? So from the last row, which is row 3, you can see that what? Z is what? Minus 2. Because remember, Z is the third column, right? And this is what we call back substitution now. So we are doing back substitution now. Let me say back substitution. This is one of the steps of what? Gaussian elimination. So if you go back to the second one, you will have y minus 9 over 5z equals to what? 13 over 5. Now we'll substitute z is equals to minus 2. So you have y minus 9 over 5. Z is minus 2. And this is 13 all over 5. So this is y plus 18 over 5. It's equals to 13 over 5. And that means that y is equals to what? 13 over 5 minus 18 over 5. And this is nothing but what? Minus 1, right? And then we can go again from row 2. This is now row, where did I get this from? This is from row what? Row 2. This is from row 3. Then we can also get from row 1 that x plus y minus 4z, it's equals to minus 13. This is coming from row 1. So you see, it's called back substitution because we started from the last row and we are going back gradually to. Now, where is this coming from? This is coming from, because this 1 is the coefficient of x, this 1 is the coefficient of y, and this minus 4 is the coefficient of what? Z. So that is why we have this. Now we substitute these things. What is x? X now, so we have x plus y is minus 1 minus 4. What is z? Z is minus 2. Everything equals to minus 13. So we'll have x minus 1 plus 8, right? It's equals to minus 13. So this is what's, this will give us plus 7 is minus 13, right? Is it? Z is minus 2, y is minus 1. And here we have what? Here. Okay. So we have to check something. So I think there's something here. This is supposed to be 10. So here all the way, I think it's 10, not because we didn't do anything to it. Here we're to keep this. Yeah, we are keeping this row. So one need to be careful. We're keeping this row here. So at this point, the pivot is what? Is this one? 1, 1 minus 4, 10. So it's actually 1, 1 minus 4, 10. So this is all 10 all the way, not. Yeah, because x cannot be minus x, it won't solve. So just look here, this is 10 from the beginning. And if you look at this step, this is still, because we keep the only row, the first row, we only change the second row and the third row to 0, this first entry. So that 10 should remain all throughout. So here, what we have here, it's 10 here. And this is 10. Okay, this looks good now. So this is 10 here. So what is x here? X is going to be minus 3. So it means our solution sets, which is x, y, z, is just what? What is x? Minus 3. And y is minus 1. And z is equals to minus 2. So this is the solution. All right. Now, this is by using what we call the Gaussian elimination. So, and you can try to check with this. I think this is going to solve the equation. So let's now try Gauss-Jordan. Let's do Gauss-Jordan. For Gauss-Jordan, we just take our row echelon, which is 1, 1 minus 4, and what? 10. 0, 1 minus 9 over 5, and what? 13 over 5. And this is 0, 0, 1 minus 2. So this is the what? The row echelon, which we obtain above, same as what we have above. Now, you see this is already 1, 1, 1. So if you want to get to reduced, you have to take all the numbers below and above this pivot entry or this leading entry to be 0. So if you look at this first one here, you don't have anything above it, so it's fine. But this second one, this guy has to go to 0. This will have to go to 0. Here as well, these two numbers will have to go to 0. All right. So how do we do that? Still by row operation. Okay. Okay, now if you look at this, what we can do is to make this 0 is by what? So now we have to try to apply some row operations so that we can convert this to 0, and that we can easily do. This one is going to be minus R1, no, R2 plus R1. Yes, we can do minus R2 plus R1 because already this is 1, right? So we want to take this 1 to 0. So we take the negative of this, multiply by this, and then we add it. So here is our fixed 1, This is minus 9 over 5. And here is 13 over 5, right? Okay. Now, what we need to do now is apply this one. So here will still remain 1. Here will become 0. So minus this is what? If you minus this, it's just going to be 9 over 5, then minus 4, right? This is what we're going to have, minus 4. And if you look at this, this is simply going to be 4. We can write 4 as what? As 20 over this. Okay. So what are we going to get? This is just going to be what? It's going to be, you can have minus 11. So let's say this will be minus 11 over what? Over 5. So this will be minus 11 over 5. All right. Now, here will still be what? 0, 0, 1. And here will be minus what? Minus 2. Now, you see that something has changed also now. Here we still have our 1, 1. We have 1, 1. So this one is good. This one is good. This one is good. So we need to take these guys to 0. We need to take this guy to 0. Remember here is 11. So we didn't finish it because we need to have what is here. What is, remember, what operation? Minus R2 plus R1. So it's minus, so we have minus 13 over 5 plus what? Plus 10. Yes, that is what we are having here. And what will that be? That is just going to be 30 watts. So the term here, what will the term be? It's just going to be minus R2. So it means it is minus R2. So that is minus 13 over 5 plus what? R1, which is plus 10. Yeah. So this is minus plus 50 over 5. So that is going to be 37 over 5. Right. Okay. Then the next thing is just as we've indicated, this one has to still go to has to go to 0. This 2 has to go to 0 because what is the pivot? Remember, the pivot are the ones in green. Let's highlight them again. When I say the pivot, I mean the leading entry. So since we are going to reduce row echelon, whatever is below and above has to go to 0. So now, to take this to 0, we can apply what? Remember, this is minus 11 over 5. So we can just use 11 over 5 R3 plus what? R1. That will do. R3 is fixed now because you are in the column 3. So this is 0, 0, 1. And this is minus 2, right? So this is going to be still 11 over 5 times 0 is 0 plus 1. So this is still 1, right? Then 11 over 5 times 0 is 0 plus 0, still going to be 0. 11 over 5 times 1 is 11 over 5 plus minus 11 over 5. This is 0. Then you have 11 over 5 times minus 2, which will give you minus 22 over 5. Then you need to add it to the term here, which is 37 over 5. And if you look at this, it's just going to be 15 over 3 over 5, which is what? Which is 3. Then finally, we have the second row. The second row, we can apply 9 over 5 R2, no, R3 still, but now plus what? R2. And this will make this to be 0. This will still be what? 1, because you have 9 over 5 R3, 9 over 5 R3 plus 1. Then 9 over 5 R3. So you have 9 over 5 times 1, which is 9 over 5, plus minus 9 over 5. This is 0. Then 9 over 5 times R3. What is R3? R3 again is minus 2. So this will give us minus 18 over 5. Then you need to add it what? With this one, because this is the R2 here. So you have 13 over 5. And this is nothing but minus 5 over 5. So this is minus 1. All right, so if you look clearly, you will see that what? This matrix already now is what? Is reduced row echelon form. So from here, you can get your solution. Your solution is simply directly, this is X, no, this is Z, this is Y, and this is X. So we will see that what? From the first row, you see that X is equals to 3. This is coming from row 1. And Y is the leading entry in the second row. It's minus 1. This is from row 2. And then you have Z, which is minus 2. This is coming from row 3. So it means, what is the solution? The solution is simply X, Y, Z. It's only one solution. And that is what? 3 minus 1 minus 2. And you can see that this is the same solution we got when we use Gaussian elimination. So if you are asked to use Gauss-Jordan, so you cannot just start from here, right? It's not possible, because you have to start from the beginning. You try to reach echelon form, then you proceed to what? Reduce echelon form. Then you read the answer. You read your solution directly from your last matrix. All right. So I hope this is clear. Thank you for watching. If you have any question, just put it in the comment section.